An aircraft carrier is what happens when a navy refuses to wait for an airport. Instead of asking for a runway on land, the Navy brings one across the ocean. The fuel moves with it. The weapons move with it. So do the pilots, mechanics, radar crews, repair shops, and thousands of people needed to keep aircraft flying day after day. The largest carriers stretch more than 3 football fields from bow to stern. Some carry dozens of aircraft, some run on nuclear power, and the biggest weigh more than 100,000 tons before the full air wing and supplies are loaded aboard. But size alone is not what makes these ships powerful. A carrier allows a country to place fighters, helicopters, surveillance aircraft, and an entire support system near almost any coastline without depending on a nearby airfield. This countdown begins with a compact nuclear carrier and ends with a ship built around electromagnetic catapults, automation, and thousands of crew members. At what point does a warship stop feeling like a ship and start feeling like a moving air force? France wanted air power that did not depend on a foreign runway. Charles de Gaulle was the answer. At about 43,000 tons, it is much smaller than the American supercarriers near the end of this list. But it carries one major advantage: nuclear propulsion. 2 K-15 reactors drive the ship at around 27 knots. They do not remove the need for food, aviation fuel, weapons, or spare parts, but they allow the carrier itself to keep moving without constantly stopping for propulsion fuel. That gives France something more useful than simple range. It gives France options. The flight deck can launch Rafale fighters using steam catapults. It can also operate E-2C Hawkeye aircraft, giving the carrier group a much wider view of the sky and sea around it. Up to about 40 aircraft can operate from the ship, supported by roughly 2,000 people. That is a small town sealed inside a steel hull, while fighter jets launch only a few decks above the crew quarters. Charles de Gaulle has supported operations connected to Afghanistan, Libya, Iraq, and Syria. In each case, France could move fighters closer to the mission without first finding a friendly airfield nearby. This is the smallest carrier in the countdown, but it allows France to bring its own runway wherever it decides to go. India had operated aircraft carriers before. Vikrant was different because this time India built the runway, the hangar, and the 45,000-ton ship beneath them. Constructing a carrier is not simply a matter of building a large hull. The ship must combine engines, radar, weapons, fuel storage, crew quarters, repair areas, and a flight deck strong enough to handle one hard landing after another. All of those systems must keep working, while the entire structure moves through salt water, wind, heat, and heavy seas. Vikrant's flight deck runs for about 262 meters and ends in a ski jump. Fighters accelerate toward the curved bow and leave the ship using their own engine power. When they return, arresting wires catch them before they run out of deck. The ship can support up to about 36 aircraft, including fighters and helicopters, with roughly 1,700 people aboard. During flight operations, the deck becomes a crowded workplace. One aircraft is preparing to launch, another is being fueled. A helicopter may be waiting nearby while crews move weapons and equipment through the same limited space. And beneath all of them, the runway is still moving. Vikrant matters because it carries aircraft. It matters even more because India proved it could build the entire system that keeps those aircraft operating at sea. INS Vikramaditya did not begin as the carrier India wanted. It began as a Soviet heavy aircraft cruiser, and much of that old identity had to be cut away. India purchased the ship from Russia in 2004. What followed was not a normal upgrade. The original missile systems were removed. Aviation spaces were rebuilt. The flight deck was redesigned around a ski jump. internal areas created for one mission had to be converted for aircraft maintenance, fuel, weapons, and flight operations. By the time the work was finished, the old cruiser had disappeared beneath a 284-meter flight deck. The rebuilt ship displaces more than 45,000 tons and can reach around 30 knots using steam boilers and turbines. It can support about 36 aircraft and helicopters, along with roughly 1,700 crew members. The transformation is easiest to understand from above. Where the old ship once carried large missile systems, the new carrier has aircraft parking areas, a runway, a ski jump, and a deck organized around getting fighters into the air. This was not simply a ship receiving new equipment. It was a warship being taught an entirely different job. Vikrant showed what India could build from the beginning. Vikramaditya showed how completely an existing ship could be rebuilt when the original design was no longer enough. China did not just rebuild a warship, it built a 61,000-ton floating classroom. Liaoning began as the unfinished Soviet carrier Varyag. China purchased the hull from Ukraine in 1998, rebuilt it over many years, and placed it into service in 2012. Its ski jump bow allows fighters to leave the deck without a catapult. But the system comes with limits. The aircraft must use their own engine power to take off, which can restrict how much fuel or weapon weight they carry during certain launches. For China, that limitation became part of the lesson. Pilots had to learn how to approach a runway moving through the ocean. Deck crews had to guide aircraft through a cramped space filled with engines, fuel, weapons, and spinning rotors. A mistake on land may delay one aircraft. A mistake on a carrier deck can block the entire runway. Commanders also had to learn how to coordinate the carrier with escort ships, supply vessels, maintenance teams, and the aircraft flying above them. Liaoning can support roughly 40 aircraft and helicopters, with about 2,600 people aboard. Its most important cargo was not the fighters parked on deck. It was experience. Every landing, deck signal, repair, and failed procedure helped China prepare for the larger carriers that followed. Liaoning was a warship, but its most important mission was teaching an entire navy how to operate one. Building carrier power is one problem. Keeping it available is another. Admiral Kuznetsov was built to intimidate rival navies. Instead, it has spent much of its life fighting its own machinery. The ship combines two different ideas. The flight deck operates aircraft from a ski jump. At the same time, the hull carries heavy anti-ship missiles, air defense weapons, and close-in guns. On paper, it is not just an aircraft carrier. It is also a heavily armed missile cruiser capable of carrying around 50 aircraft and helicopters. At roughly 65,000 tons, Kuznetsov carries plenty of weapons. The problem begins below the deck. 8 boilers and 4 steam turbines burn heavy fuel oil. When the system is not running cleanly, thick black smoke can follow the ship for miles. The propulsion system has also suffered repeated technical problems, and that creates a simple weakness. A carrier may carry fighters, missiles, radar, and thousands of people. But none of that matters if the ship cannot leave port reliably or remain available when needed. Kuznetsov entered a long repair and modernization period in 2017. Return dates have moved more than once, and the ship's future remains uncertain. It was built to project Russian power far from home. Instead, its longest-running battle has been with its own engines. Kuznetsov showed what happens when the machinery cannot support the mission. Shandong represents the opposite approach. Take the lessons from an older carrier and build the next one around them. From a distance, Shandong looks a lot like Liaoning. That is not an accident. China was not trying to invent carrier aviation again. It was trying to make the system less crowded, less improvised, and easier to repeat. The ship is larger than Liaoning, displacing roughly 70,000 tons. But the more useful difference is the extra working space. The hangar is larger. The island structure is smaller. The flight deck gives crews more room to park, move, fuel, and prepare aircraft. On a carrier, empty deck space is never truly empty. It can become a parking position, a fueling area, a movement lane, or the place where the next fighter waits before launch. When the deck becomes too crowded, aircraft begin blocking one another. Shandong gives the crew something every carrier desperately needs: room to breathe. The ship can support about 50 aircraft and helicopters, with roughly 2,500 people aboard. It has also operated as part of Chinese naval groups in the South China Sea and Western Pacific. Liaoning taught China how carrier operations worked. Shandong showed that China could build a carrier around those lessons instead of borrowing the classroom again. Most aircraft carriers must throw a fighter into the air and catch it when it comes back. HMS Queen Elizabeth was built around a fighter that can do much of that work itself. Its main aircraft is the F-35B. The jet accelerates toward the ski jump and uses a short takeoff to leave the deck. When it returns, it does not need to catch an arresting wire. It can hover beside the ship and lower itself onto the runway. That changes the entire layout. A traditional carrier needs heavy catapults for launch and arresting equipment for recovery. Queen Elizabeth avoids both by using an aircraft designed for short takeoffs and vertical landings. The carrier is shorter than several ships on this list, but its wide flight deck was designed around this unusual style of operation. At roughly 65,000 tons, it is the largest warship ever built for the Royal Navy. It can operate F-35B fighters along with helicopters used for anti-submarine missions, transport, rescue, and support. Around 1,600 people can support full air operations aboard the ship. That is fewer than the population carried by an American supercarrier, but still enough to fill a small town. Gas turbines and diesel engines generate electricity for an integrated electric drive, pushing the carrier beyond 25 knots. Queen Elizabeth does not try to copy the American carrier system. It changes the aircraft instead. The ship does not catch the fighter. The fighter brings itself home. For China's first two carriers, the ski jump decided how heavily an aircraft could leave the deck. Fujian was built to remove that restriction. Instead of sending fighters up a curved ramp using only their own engines, Fujian uses electromagnetic catapults built into the flight deck. The system pulls an aircraft forward and helps it reach takeoff speed in a much shorter distance. That means heavier aircraft can potentially launch with more fuel, more equipment, or a larger weapons load. It also opens the deck to aircraft that would struggle to use a ski jump. That includes larger aircraft, such as the KJ-600, an early warning plane designed to watch far beyond the carrier's own radar. Fujian is about 316 meters long and displaces roughly 80,000 tons. But almost everything important about the ship comes down to 3 narrow launch tracks built into its deck. The deck works like a production line. One aircraft moves into position, another waits behind it. Fuel crews, weapons crews, inspectors, and deck handlers all work around the launch area. Nothing can be random. Fujian's full operational capability still depends on testing, training, and the aircraft developed to operate from it. But the goal is already clear. China's earlier carriers taught pilots how to leave a ski jump. Fujian is designed to launch the aircraft that a ski jump leaves behind. A crew of around 5,000 people is not normal for a ship. Neither is an air wing filled with fighters, helicopters, surveillance planes, transports, and electronic warfare aircraft. USS Nimitz was built around both. At 333 meters long and around 100,000 tons, Nimitz carries enough people, aircraft, fuel, and equipment to operate like a small military town. 2 nuclear reactors give it enormous endurance and push it beyond 30 knots. 4 steam catapults launch aircraft too heavy to rely on a ski jump. But the real scale becomes clearer below the flight deck. About 3,200 people operate the ship itself. Roughly 1,800 more support the air wing. Together, they form a moving community larger than many small American towns. The carrier must feed them, house them, treat injuries, maintain nuclear reactors, store weapons, repair aircraft, and keep the runway above them working. All of that happens while the ship crosses rough water and the deck is exposed to wind, salt, heat, noise, and jet exhaust. Nimitz entered service in 1975 and became the first ship in a class of 10 carriers. That long career is the real proof. Many giant machines look impressive once. Nimitz had to do the same difficult job over and over again. Aircraft launched, aircraft returned, crews rotated, parts wore out, repairs were made, supplies arrived. Then the ship deployed again. Nimitz did not simply prove the supercarrier could be built, it proved the supercarrier could become routine. Gerald R. Ford is only a few meters longer than Nimitz. So from a distance, the future of the aircraft carrier looks almost the same. The difference begins when the aircraft start moving. Ford replaces the steam catapults used by the Nimitz class with electromagnetic launch systems. It also uses advanced arresting gear to bring aircraft back onto the deck. Together, these systems are designed to handle different aircraft more smoothly and support a faster flight schedule. The carrier stretches about 337 meters and displaces more than 100,000 tons. 2 nuclear reactors power the ship and provide the electrical energy required by its newer systems. The air wing can include fighters, early warning aircraft, electronic warfare planes, helicopters, and tilt-rotor transports. But Ford's biggest goal is not simply carrying more aircraft. It is moving them faster, launch them, bring them back, refuel them, rearm them, repair them, then do it again with fewer people handling the process. More automated systems are designed to reduce crew requirements. Ford carries roughly 4,600 personnel, still an enormous population, but fewer than the total commonly associated with a Nimitz-class carrier and its air wing. That ambition came with a price. New catapults, new arresting gear, new weapons elevators, and more automation meant replacing several proven systems at the same time. The lead ship became both an aircraft carrier and a full-scale test of how the next generation was supposed to work. That created delays, technical problems, and a long path toward dependable operations. Ford was not built merely to be larger than Nimitz. It was built to get more work from the flight deck and fewer sailors below it. At more than 100,000 tons, it carries the runway, the aircraft, the repair shops, the command center, and thousands of people across the ocean together. Nimitz made the supercarrier repeatable. Ford is trying to make it more efficient. These carriers grow from about 43,000 tons to more than 100,000, but size alone does not decide what makes one powerful. Charles de Gaulle gives France an independent runway. Liaoning trained a new carrier force. Kuznetsov shows what happens when reliability collapses. Nimitz proved the supercarrier could work for decades, while Ford is trying to change how that work gets done. Which matters more? Proven endurance, better launch technology, or a more automated flight deck? Tell us below and subscribe to Megamass for the next machine built beyond ordinary limits.